Let's try another word problem. So let's say I start off with a square piece of paper and I don't know what the size is. It's a square. But that's all I know so far. And what I'm going to do is I'm going to take that square and I'm going to cut 4 squares out of it. So that I can fold this up and make a box of volume 20 cubic inches. Okay, so what do I mean by that? Well, I mean I'm going to do something kind of like this. I'm going to take some piece of paper and I'm going to cut out very precisely squares which are each perfectly square and the exact same size. And then I'm going to fold to make a beautiful, perfect box. There you go. I could do a better job if I want to tape this together, but actually this is a bad approximation because I didn't start with a square piece of paper. I'm doing this with a square to start. But I don't know what that size is. So I'm told that I cut out 2 by 2 squares from each corner of a square piece of paper. And let's say when I'm done, the volume is 20 cubic inches. Okay, so that's what I know. And the question is what is the length of the paper? That's what I want to know. Okay, so this is what I want to find. I'm going to call that length x. So we have this x by x piece of paper. And I cut out these 2 by 2 squares. And at the end, the volume is 20. And we'll assume everything's in inches. I could have done the same problem with everything in another unit as long as it's the same unit throughout. Let's stick to inches for this. So, what do I know? Well, we have to write down what we want to find, and then we have to write down everything we're told, and then we probably won't know what to do, and then it might be a good idea to try to see if there's anything we could plug to simplify. Okay, so what is the volume going to be? Well, it's the length times the width times the height. Now, what is the height? Well, the height of this is going to be this here, which is the part we cut out. So the height is going to be 2. So I know that the volume is length times width times height, and that the height is 2. Okay, well I need the length and the width. So the length is not the length of the paper. The length of the box is this. Well, what's that? What's this? It's going to be x minus 2 minus 2. So that tells me that the length is x minus 4, the width is x minus 4, and I know that the volume, which I haven't written down in sort of this notation, is 20. Okay, so maybe I don't know what to do. Let's see if there's anything I can plug. There's lots of stuff I can plug. So I get 20 is equal to x minus 4 times x minus 4 times 2, which tells me that, well, I could divide both sides by 2 to make it a little easier. 10 equals x minus 4 squared. Okay, I have a quadratic equation. How do I solve it? Well, lots of ways I could solve it. I could multiply this out, move everything over to one side, try to factor, maybe fail with the factoring, say I'm going to use the quadratic formula, and get an answer. Or I could remember, hey, the quadratic formula is just completing the square, and this is already a perfect square. I have a square equal to a constant. That's where the whole completing the square idea came from. So, what I really want to know is I really just want to know, hey, this quantity squared is 10. What's that quantity? And that quantity is x minus 4. So I can use my rule for radicals right off the bat and just get that x minus 4 is plus or minus root 10. Or x is equal to 4 plus or minus root 10. So that is my answer. I have two answers, or do I? Well, 4 plus root 10 and 4 minus root 10? Let's think about that for a minute. Do both of those really make sense? Remember, I'm taking my piece of paper and I'm cutting out squares of length 2 by 2. These are 2 by 2 squares. So I'm taking 4 inches off the paper. So let's go back here. Which one of these numbers could I subtract 4 and have it still make sense? If it's 4 minus root 10 and I cut away 4 of it, I'm going to have a paper of negative length, which might make sense in some sort of a pseudo-antimatter strange dimension, or philosophically it might mean something, but in terms of our actual problem, that doesn't make any sense at all. So the only possibility is not this one. If it's 4 plus root 10, then when I cut 4 off of it, I will still have a positive number. Okay, so that actually is what I wanted to find. I wanted to find x. And I know that x is 4 plus root 10, so I'm done. But you know what? We did a lot of work. This is a long problem. So let's check it. So, if x is 4 plus root 10, and I cut off 4 inches, my box is going to be root 10 by root 10 by 2. Remember, I had 4 plus root 10 for the length of the paper, and I cut away 4 inches. So I'm left with root 10. So that's the length times the width times the height. Okay. If I multiply this together and I get 20, then I know I did the problem right. Well, what do I have? And that tells me what I had was correct. So this was my answer. And that's an example of another word problem, which turns out to, it amounts to being the solution to a quadratic equation.